Okay, here we're going to look at the atomic basics and how they relate to biology. So when we think atomic, when we think basics here, you may be first wondering that how are biology and this is like chemistry connected? Well, we're kind of born along the lines of what we call biochemistry. Since biology is a multidisciplinary science, living organisms are subject to basic laws of physics and also chemistry. So in this particular lecture, we're going to divide a little bit into the very small end of chemistry. These activities sustain life and depend on the properties of atoms, molecules, and a compound. And if we don't understand kind of what's going on at the very small level and realize how it can impact us on the very large scale. So first off, atoms. What are they made out of? Well, we can see here in the center nucleus, we have our protons and our neutrons, and our electrons are on the outside. See the same thing here with our protons and neutrons on the inside and our electrons around that nucleus. So organisms are composed of matter. So I figure I should probably define what matter is. Well, matter is anything that takes up space and has mass. So it could be this rock, could be the plants, could be the building, could be this bird, could be the tree that this bird is on. All of these are composed of matter because they take up space and they have mass. So properties of matter. Well, there's physical properties which are based on observations that do not alter the composition of the matter. So when we're looking at properties or measuring properties of matter, two of those that we could do would be mass, where it's the property of matter that measures its resistance to acceleration, or a general measure of the number of atoms present. Another physical property regarding matter would be volume, and it's the amount of space an object takes up measured in cubic units. So we think about mass here, again, just basically the measure of the number of atoms present, and volume is the space that an object will take up. Density is a measure of mass per volume. So how do we kind of relate those two? Would be density. And we see here in this graduated cylinder, different liquids of different densities. Those that are more dense will be located on the bottom, and those that are less dense will be more on the top. When we say less dense, those molecules are spaced out greater. When we say more dense, there is more mass per volume. The basic atom, as we mentioned before here, is our protons and neutrons located in the nucleus, and our electrons on the outside. What this image adds that the others did not is that the protons have a positive charge, neutrons are neutral, and electrons have a negative charge. Atoms are the smallest unit of matter, and the atoms are made of these protons, which are positively charged, and they also determine the atomic number and therefore the element. So we want to determine the element, we look at the proton number. Neutrons simply have a neutral charge and are located in the nucleus. Electrons have a -1 charge and circle the nucleus. Typically we'll see them kind of labeled like this, with neutrons with a 0 here indicating a neutral charge, electrons with the E with the minus sign indicating a negative charge, and protons with the plus indicating a +1 charge. An excellent table to kind of go over, review, and commit to memory would be this one right here. It gives you the particle name, electrons, protons, and neutrons, their location, whether it's in the orbitals on the outside or located in the nucleus, and the charge, where electrons are -1, protons +1, neutrons are neutral or no charge, and the mass. Protons and neutrons have a mass of 1, and electrons we say about 0. Say about 0 because for the intents and purposes of this class we're going to consider it to be 0, but there is a very, very small mass there, so that's why it's about 0. It's a very small, minute number. For our easy math calculations, we'll pretty much consider it a mass of 0. Now the atomic number and atomic mass, atoms of various elements differ in the subatomic particles. An element's atomic number is the number of protons. So here we see magnesium has 12 protons, every oxygen atom will have 8 protons, and here hydrogen will have an atomic number of 1, indicating it has 1 proton in its nucleus. The numbers below here we see our average atomic weights, which we'll talk about later. The element's atomic mass number is the sum of protons plus neutrons in the nucleus. So referring to atomic weight, we're adding up the protons and the neutrons since they accompany the vast majority of the mass of the atom. Now it's an average atomic weight, which I'll talk about in other lectures. That's why you get into these decimal points. and international atomic weights here for all the elements. You can find those easily on the periodic table of elements. So the atomic number and the atomic mass. The atomic or mass number is the sum of protons and neutrons. And down here we see the atomic number, which is the protons in a neutral atom. This is the same as the number of electrons. So the proton number will not change for helium, but when we say it's a neutral atom of helium, 2 of those protons we know are present, therefore we need 2 electrons with their negative charge to balance out the positive charge. Atoms have 2 regions, the electron cloud, which takes up the most space and is an area where electrons circle the nucleus. That is the outside portion here, here. The nucleus is made of protons and neutrons and determines the atomic mass, and that's the center region here. So this large positive charge, because remember our neutrons also located in the nucleus have a neutral charge. This electron cloud often confuses students, kind of like, what is it? It takes up the space and atoms circling the nucleus. It's kind of like this example here. The electrons here are the birds, and the person here in the center is representing the nucleus. And the electrons, kind of like the birds, are kind of centering around this nucleus. Most of those birds will be found around that person or representing the nucleus, but there'll always be a few here to the outside. Kind of looking at a density standpoint, we see a more dense located here and less dense to the outside. This is why we call this an electron cloud, because there's not really particularly set orbitals. It's kind of this cloud region that you kind of see this darker shading or more dense located around the nucleus and less dense around the outside. Lastly, elements. Matter is made up of elements, and an element is a substance that cannot be broken down to other substances by chemical reactions. So we see here just generic elements all listed here being combined and broken apart. The most basic unit here is our elements. And we're going to refer to and study more the periodic table of elements, but hopefully this gave you just a general basic overview of atoms.